3.6. 3.7 is not part of this course. And we have 3.8, which is implicit differentiation, and we have 3.9. So we have 3 sections left from this chapter. Since I have 5 minutes, I just want to give you, you're not responsible for anything here, but I just want to show an example from 3.8. 3.8 is a very simple situation. I shouldn't say simple. I should say is a very doable type of problem. So 3.8, and I'll stop in a couple of minutes, I promise. This is entitled implicit. We're gonna have many more examples on Wednesday. So this is another application. So again, graphing, absolute max min of any type. And now this is implicit differentiation. What does this mean? So what is implicit? So if I have a function f of x equals 3x squared plus e to the x, the function is given to us directly. I have the function. So now, can anyone help with f prime? If I have the function, easy to find f prime. Can anyone give us f prime for this function? I know you're tired. Just to help me out here, 1 more minute. I promise.
6x plus e to the x.
That's it. But let's take a look at the following equation. And after this, I'll stop, I promise. What if I have 3y squared plus xy equals 4x to the third? And we're asked to find y prime. I cannot solve this. I cannot. Say it again, Garby?
I say you won't be able to solve it.
Correct. Can I find an expression for y prime? Yes. How? Implicitly. Because the function is not given to us directly. I cannot directly differentiate, but I can find an expression for y prime using a method called implicit differentiation. So how I'm going to do it? I'm going to differentiate both sides. How come? Well, in the same way, 20 minutes ago, we applied natural log to both sides. If I am allowed to apply natural log to both sides, I am allowed to differentiate both sides. As long as I can do it in the same way, I apply the same procedure to both sides, I am allowed to. Okay, but I have to remember that y is a function. So I'm going to put a little sign underneath y, a little colored dot, to remind me that y is a function of x. In addition, I'm not going to use this notation. Nothing wrong with it. But this is a better notation, dy over dx. This may be lost in the equation, but this one will not be lost in the equation. Better notation for implicit differentiation. So when I differentiate both sides, this is a function. 3 times 2 is 6. Y to 2 minus 1 times the inner function prime. Plus, this is a product, I have to be careful. First function prime is 1. Plus the first function times the second function prime. The right-hand side, 12x squared. What am I after? This This is my variable. So I'm going to move y to the other side and factor out these two. So 6y plus x dy over dx equals 12x squared minus, because it was positive, minus y. That's it. I'm done. I found an expression for dy over dx, this over this. You can say, yeah, but you still have y in it. Sure, but I found an expression for the derivative of y